All right, so we got the factoring review taken care of. Now this is simplifying rational expressions. This is the first unit of the grade 11 course, and we're covering almost everything that you do in that unit in one day, and it won't even take us that long. And again, there's going to be a ton of factoring involved here, and it's going to be easy factoring for these examples, but it's going to be, an example of the kinds of questions that we're going to do in this course, and how these skills are really just getting us started, and then there's all these other things that we have to do. So these expressions, these rational expressions, are things we're going to see a fair bit of throughout this course. And so the instructions are simplify each expression and state all restrictions. So I'm going to talk about restrictions a little bit more when we get there. Let's start the first one. So how are we going to simplify this? Well, I can see that on top it has a difference of squares. So I'm going to go ahead and factor that. And what I have here is a common factor on top and bottom, and they divide to 1. So what's actually happening here, right, is I could rewrite this like this: x plus 6 divided by x plus 6 times x minus 6. And anything over itself is 1, so that's gone, right? So those do cancel. And this is equal to x minus 6. Now, what does that mean? What does it mean for this original one to be equal to that one? We're going to talk about this in terms of functions and graphs later on in this course. For now, it means for any value of x that I plug in to either the top expression, the original expression, or the simplified version, if I put 10 in for x, I will get the same output, the same result in both cases. That's what it means for them to be equal. They are equal. But there's one value that they're not equal for. If I plug -6 into our simplified expression, I'll get -12 as the result. If I plug -6 into the original expression, what do I get? I get 0 on the bottom, which is undefined. You can't divide by 0. So that's what a restriction means. As long as we're not looking at an x value of -6, those two expressions are always equal. That's why we need a restriction. Okay, and that is something that is just, you're taught to do it in grade 11, but in this course, we're going to see why we have to do that. In this course, we're going to have times where, if we miss the restrictions, our answer to the question would be wrong. Not just because we're missing the restrictions, but for other reasons, okay? So this is nice thing about this course is we start to see why a lot of the rules in math that you've been learning and just taught to do just because, we start to see why they're actually true. It's kind of cool. All right, so same thing. So, but if you are just following the procedural steps, then your first step when you come across a question like this is to factor everything. There's a couple of things that you could do, and it doesn't matter what order that you do them in, or you could do them all in the same step. I'm going to go a little bit slow, one step at a time here. So I'm factoring the top here. It's a simple trinomial. Looks like x minus 7 times x plus 4 over x plus 5 divided by another simple trinomial. See what I mean? The factoring's easy. X plus 4 over x minus 2 all over another simple trinomial. And what we actually notice, either before we factor it or after, is that that was a perfect square trinomial. We talked about that in the factoring review. That's a perfect square trinomial because the square root of 25 is equal to half of 10, okay? And the signs all line up and work and everything. So that's a perfect square trinomial, and I'm going to rewrite it as x plus 5 squared in the next step. But you don't have to. There's no rule that you have to. In some cases, we sort of will have to in this course, but for now, there's nothing in there that means we have to. Okay, so I'm just rewriting this because when you're dividing by fraction, what's the trick that we usually use? We flip and multiply. There you have it. Now, now we can start doing our canceling. Okay, so I've got an x plus 5 on the bottom over here, and only because I'm multiplying. If you're adding, you can't do this. I hope you remember that. Is going to cancel with one of the x plus 5s there, and we'll be left. We'll have one left over. And I got an x plus 4 here and an x plus 4 here that will be left over. Okay, and now I'm going to shove all of this together. So I've got an x minus 7 left on top and an x plus 5 left on top. And I've got an x minus 2 left on the bottom. Now, I'm going to talk about something probably a little bit differently than how you learned it in grade 11. Don't get hung up on this. You can do it either way. We'll talk about this again down the road, probably. When we start to do more of this, it'll come up again. And if you have questions, ask about it when we see each other next. I believe you were taught in grade 11 that anytime you divide by something, it becomes a restriction. I don't necessarily see it that way. So for me, when I look at this, I go back to that idea that I was just talking about, that this expression and this expression are equal for all values of x except which values. And I would say those values are when x is equal to -5 or -4. So I believe in grade 11 you would have also included when x equals 2. Why am I not including that one? It's not wrong to include it, but the reason why I wouldn't include it and I wouldn't bother to include it is because these expressions actually will be equivalent when x equals 2. They'll both not work. This will still be dividing by 0, and you can't divide by 0, so it will give me an undefined result. And if I tried to plug 2 into the original, it would be the same thing, because I would be dividing. See how I'm dividing here? So I would be dividing by 0, and it would give me undefined. So these two expressions are actually the same when x is 2. So that's why I would say that restriction is not required. It's not wrong if you put it, if you just want to put it because you want to put everything, that's fine. You know, you couldn't put a restriction like when x equals 7, because that's not true. When x equals 7, both would result in a value of 0, and that's fine. There's nothing wrong with that. Okay. But the reason why we have the real reason why we have restrictions is because what we have said is the original expression and every step along the way are all equal to each other except at these certain values. So those really are the only values we have to include for our restriction set. Okay, I hope that makes sense. So that kind of means anything that gets divided out is going to be a restriction, right? Because it's disappeared and it's no longer in your final result. Okay, we got one more. This is the hardest kind because we're adding. So adding is very different from dividing and multiplying. And so the first thing we're going to do is we have one last new thing to talk about as well that comes up in this question, which is neat. So the first thing we're going to do is factor everything. Okay. Now we have to have a common denominator to add fractions. And so we have to look at what we have in the first one and look at what we have in the second one and see what's missing. So I'm missing an x plus 3 in the first, and I'm missing an x plus 1 in the second. So how do I get those in there? Well, I use the trick that when you multiply by 1, oops, I don't want that to be that long. When you multiply by 1, you don't change something. So what I can do is x plus 4 times x plus 1. I multiply that by x plus 3 over x plus 3. So I'm multiplying by 1. Multiplying by 1 doesn't change anything. 5 times 1 is 5. 10 times 1 is 10. X times 1 is x, right? I haven't changed anything. but when I actually carry out the multiplication, I'll have an x plus 3 factor on the bottom, which is what I want. And this is going to be 1 over x plus 3, x plus 4, and I'm going to multiply that one by x plus 1 over x plus 1. Now, you don't need to show this step. You certainly don't need to do this in two separate steps, and you don't need to show that you're doing that. You could go straight to the 2x plus 3 over x plus 4, x plus 1 times x plus 3 plus 1 times x plus 1 all over x plus 4, x plus 1, x plus 3. So now you see we have a common denominator. And again, you wouldn't have to show that step. So I showed 2 extra steps that I don't have to in that case. Okay. And then, so you could go straight to this. And you don't need those brackets, 1 times x plus 1. I'll show it that way for now. X plus 4 if you want. But you know, if you're skipping steps and you make mistakes, then the only thing you can do is stop skipping steps, take your time, slow down, and write more steps, and that will cause you to make fewer mistakes, because we often make mistakes when we're trying to do too much all at once. Okay. Now here's the last thing that we need to talk about. What do I expand? Right? Like, and this is a hard thing in grade 11, like to know when do you factor, when do you expand, when do you this, when do you do that. And absolutely I have to expand and simplify the top here. And this is something that you're going to really need to get used to knowing when to do this and when not to. What about expanding the bottom? Well, no, because it's fully factored, and expanding it's not going to help. And how do you know? Well, with experience. It's really the only way that you can know that expanding the bottom would not help. Okay, 2x plus x is 3x, 6 plus, whoops, I made a mistake there, 3, Okay, the last one we're doing here is adding. So, you know, adding is different from multiplying and dividing and all that, and that's very different steps. So it's important that we go over it. And there's one other thing that's going to come up in this question that's going to be important to talk about. The one good rule of thumb is when you're doing these kinds of things, the best first step to do is factor everything. So this is going to be 2 over x plus 3 times x plus 1 plus 1 over x plus 3 times x plus 4. So now the reason why we do this is because now we can look for a common denominator. That's what you need to add. And I can look and see what is common and what has to be added in to make them common. So I've got an x plus 3 in both, but I'm missing x plus 4 in this one, and I'm missing x plus 1 in this one. So I have to add those in. Now the next 3 steps that I'm going to write out could all be done kind of in one step, but I'm going to write them out and talk about them. You know, we're still warming up, it's still early, and it will give me a chance to talk about some of the little things. So how do I add the x plus 4 factor to the bottom on that side? Well, I'm going to rewrite this. We use this trick that when you multiply by 1, you don't change something. 5 times 1 is 5, 10 times 1 is 10, x times 1 is x. So I can multiply by x plus 4 over x plus 4, okay? And then plus 1 over x plus 3 times, whoops, x plus 4 times, and I want to add x plus 1 to this one, so x plus 1 over x plus 1. Okay. Now, so, and when I multiply this through, carry out the multiplication, I'll get that x plus 4 factor on the one and the x plus 1 factor on the other, and I'll have a common denominator. You don't have to show this step. I'm showing just to give one for once, you know, next time I won't show these steps, but I'll show it this time just to take it nice and slow and explain exactly what we're doing. A little reminder, hopefully we remember. X plus 3, x plus 1, x plus 4, plus 1 times x plus 1 over x plus 3 times x plus 1. I'm just going to write them in the same order so that we can see for sure they are common denominator. And so now I can add the tops, okay? And that becomes 2 times x plus 4 plus 1 times x plus 1, you don't need the 1 there obviously, over our common denominator. So we've got it. So you could have done all three of those steps in one step as long as you can do it in your head. Skipping steps, I mean, that's not skipping steps because we're at a point where that's like we can follow all of that in one step. And anybody would know how you went from here to there, that you got a common denominator, okay? We're at a place where we can see that. So it's not skipping steps, but you're not showing every little step, and that's fine. The thing about rushing too much and doing too much at once is it will cause you to make mistakes. So if you are doing this, or if you're trying to actually skip steps and you make mistakes, then you have to realize and you have to go back and show more work, and that's something you just have to reflect on for yourself. But that is a way where if you tend to make careless mistakes, you know, one of the best things that you can do is slow it down and start showing more steps. Don't try to do all as much in one step, because what you're doing is you're trying to do all of that in your head and you're losing track of something along the way. Okay. Now we're going to multiply that. Here's the last thing that we need to talk about for this. So am I done, or do I have to keep going? And we do have to keep going, but this is something that's hard for people in grade 11 to realize. When do I factor? When do I expand? When do I simplify? When do I not have to do those things? And the only way you really know is through experience. That's how it's going to happen. Through experience, you're going to figure that out. But in this case, yes, you have to expand and simplify the top. Do I have to expand and simplify the bottom? No, I don't. Why? Well, it's already fully factored, and expanding is not going to help. And again, you only know that through experience. And that's why we practice. When you do enough of these, it becomes intuitive and obvious why we do expand in some cases and not in other cases. But I can't just explain it to you. It's not just intuitively obvious in the beginning, okay? So that's when you kind of just have to practice and memorize the steps a little bit, or follow a model, that kind of thing. So this becomes 3x plus 9 over x plus 3, x plus 1, x plus 4. And are we done? No, we're not done, because the top is factorable, and that is exactly the reason why we expand and simplify, is because what if the top factors and I can continue to simplify? And look at that. It's almost like this question was designed to work out such that there was more to do. So this question really does have almost a little bit of everything in it. Like, it's kind of as big a question as you can get. So that and that divide to 1, and it equals 3 times x plus 1, x plus 4, as long as x does not equal -3, because if it's equal to -3, this one will evaluate just fine, but all the steps above it will not. Okay, so that's the one I need. You don't have to write in those two values as restrictions, which would be -1 and -4. You don't have to. If you chose to, then you could, I suppose, it'd be fine, but you don't have to. Okay, so that is our fairly quick review of simplifying rational expressions. Unit 3 will be on rational functions, so we're going to see a lot more of this then, but it's just good factoring review, and it's good review for little bits and pieces of stuff that we're going to do over the first 3 units of this course. Okay, good luck with that.